Imagine a machine that doesn't just calculate faster, it redefines what can be calculated at all. That's quantum computing, and it's already at work in labs and boardrooms, reshaping industries in ways most people haven't even noticed. You might think of it as a speed upgrade for computers, but that's like calling a rocket a faster horse. Quantum computing solves problems classical systems can't touch, like modeling complex molecules for drug discovery or optimizing global supply chains in real time. The U.S. National Science Foundation reports quantum advancements could revolutionize everything from materials science to artificial intelligence. This isn't just about faster processing, it's about unlocking possibilities we didn't know were there. So what exactly is quantum computing doing under the radar, and why should you care? Let's take a closer look at the revolution that's happening in silence. Quantum key distribution, or QKD, is not just another encryption method, it's a fundamental shift in how we secure information. Unlike traditional encryption, which relies on mathematical complexity, QKD uses the principles of quantum mechanics to ensure security. If someone tries to intercept the key, the very act of observation alters the quantum state, immediately alerting the communicating parties. This makes the system theoretically unbreakable. In 2022, Chinese researchers demonstrated QKD over a record 1,200 kilometers using a satellite, proving its feasibility across vast distances. Meanwhile, the U.S. National Science Foundation has invested heavily in quantum networks, recognizing their potential to protect critical infrastructure. As quantum computing advances, so does the need for quantum-safe security. This isn't just about keeping data private, it's about redefining trust in the digital age. In 2017, China launched a satellite named Micius, achieving a breakthrough in quantum communication by transmitting entangled photons over 4,600 kilometers. This feat demonstrated the practicality of quantum key distribution on a global scale. Unlike traditional encryption, quantum communication ensures that any eavesdropping attempt would be immediately detectable. Researchers at the Chinese Academy of Sciences confirmed that the satellite maintained quantum entanglement across vast distances, a critical step toward secure global networks. A recent report from the U.S. National Science Foundation highlights how quantum advancements could revolutionize fields like drug discovery and logistics by solving complex problems beyond classical computing capabilities. Consider how this technology could safeguard sensitive data in finance or defense. Micius didn't just break distance records, it laid the groundwork for a new era of secure, quantum-powered communication. As we look ahead, the implications stretch far beyond speed. In the race to develop life-saving medications, quantum computing is rewriting the playbook. Traditional methods can take over a decade to bring a drug from concept to market, but quantum simulations offer a faster path. By modeling molecular interactions with atomic-level precision, quantum systems can predict how drugs behave in the human body, something classical computers struggle with due to the sheer complexity. A recent report from the U.S. National Science Foundation highlights how quantum computing could revolutionize this process, enabling researchers to simulate molecular behavior far more efficiently. Consider the case of protein folding. Quantum algorithms have already demonstrated the ability to simulate this process with greater accuracy than ever before. This isn't just theoretical. Pharma giants like Merck are partnering with quantum firms to explore these possibilities. As the technology matures, it may not only speed up drug discovery, but also unlock treatments for diseases we once thought intractable. This brings us to the next frontier: quantum computing's role in materials science. In 2021, IBM and Roche made a breakthrough by using quantum computing to simulate how a drug molecule interacts with a protein. This experiment marked a pivotal moment in drug discovery, where quantum systems can model complex molecular reactions far beyond the reach of classical computers. Researchers say such simulations could cut years off the drug development timeline, which typically takes over a decade from lab to market. A recent report from the U.S. National Science Foundation highlights how quantum computing is expanding what's possible in molecular science, particularly in cases where classical systems hit computational limits. Consider the staggering complexity of a single protein. It can fold into billions of configurations, each influencing a drug's effectiveness. By simulating these interactions, quantum computing offers a new lens through which scientists can design therapies. This collaboration between IBM and Roche is not just a technical achievement, It's a glimpse into a future where quantum power reshapes medicine. As the field advances, it's clear that the revolution isn't just about speed, but about solving problems once thought impossible. Simulating complex molecules has long been a bottleneck in scientific discovery. Classical computers, despite their power, hit a wall when modeling systems with more than a few dozen atoms. A recent report from the U.S. National Science Foundation highlights how quantum computers can tackle these simulations exponentially faster, opening doors to breakthroughs in materials science and medicine. Take drug discovery. Researchers say quantum systems could model protein interactions in days, a task that might take classical machines years. Picture this, designing a molecule to target a specific enzyme in the human body. Today, that process is slow and costly. With quantum computing, scientists could iterate thousands of designs in parallel, dramatically accelerating cures for diseases. This isn't just faster computation, it's a shift in what's possible. As we look at the next frontier, we'll explore how quantum hardware is evolving to meet these demands. Imagine a world where treatments are tailored not just to symptoms, but to your unique genetic code. Quantum computing is bringing this closer to reality. Researchers at institutions supported by the U.S. National Science Foundation are already using quantum algorithms to analyze genomic data at speeds classical systems simply can't match. A recent study found that quantum methods can process complex genetic interactions in hours, a task that would take traditional supercomputers weeks. Take drug discovery, quantum simulations can model molecular behavior with such precision that scientists can design therapies targeting specific mutations. This isn't just faster computing, it's a shift toward medicine that adapts to individuals, not the other way around. As these systems evolve, they could transform how we treat diseases like cancer, where one-size-fits-all approaches often fall short. The implications stretch beyond labs, reshaping the future of patient care. And as we look further, the next frontier awaits in quantum-powered diagnostics. In 2020, researchers harnessed quantum algorithms to analyze gene expression patterns with a speed and precision that classical methods simply couldn't match. This breakthrough didn't just save time, it opened new pathways in personalized medicine and genetic research. A recent report from the U.S. National Science Foundation highlighted how quantum computing can tackle problems where complexity overwhelms traditional systems. Take drug discovery. Simulating molecular behavior, which classical computers handle slowly, becomes dramatically faster with quantum techniques. Picture this, analyzing vast genomic datasets to identify disease markers, a task that might take weeks on classical systems could be condensed into hours. Researchers say this efficiency is reshaping how we approach genetic disorders. As quantum algorithms evolve, their impact extends beyond speed. They're enabling deeper insights into biological systems. This shift is not just incremental, it's transformative. As we look ahead, the next scene explores how quantum computing is changing the face of artificial intelligence. In the intricate dance of global supply chains, quantum computing is emerging as a game changer. A recent report from the U.S. National Science Foundation highlights how quantum systems can tackle optimization problems that baffle classical computers. Picture this, a logistics company managing thousands of delivery routes daily. With quantum algorithms, they could cut fuel costs and delivery times by optimizing routes in real time. Take inventory management, another area where quantum computing shines. By analyzing demand patterns and supply fluctuations with unprecedented precision, companies can reduce overstocking and shortages. Researchers say quantum computing could slash inefficiencies in these systems by up to 30%, translating into billions in savings annually. This isn't just about speed, it's about redefining efficiency in ways we're only beginning to grasp. As quantum hardware matures, the ripple effects will extend far beyond the lab. DHL is pushing the boundaries of logistics with quantum computing. In 2023, the company collaborated with quantum technology firms to test optimization models for global supply chains. These experiments aim to solve complex routing and scheduling problems in real time, something traditional systems struggle to manage efficiently. Researchers say quantum algorithms can process vast datasets and variables simultaneously, slashing decision-making time from hours to seconds. A recent report from the U.S. National Science Foundation highlights how quantum computing excels in scenarios where complexity overwhelms classical computation, such as logistics or drug discovery. Take DHL's pilot project. It's designed to simulate thousands of delivery routes across continents, factoring in weather, traffic, and fuel costs. The results could redefine efficiency in global shipping. As quantum hardware matures, these trials may soon shift from theory to practice. This innovation isn't just about speed. It's about reimagining what's possible in supply chain management. In the high-stakes world of finance, quantum computing offers more than just speed, it promises smarter decisions. Portfolio optimization, for instance, is a problem of staggering complexity, with trillions of variables to weigh at once. A recent report from the U.S. National Science Foundation highlights how quantum systems could process these variables more efficiently than classical computers, potentially identifying optimal investment strategies in a fraction of the time. Take risk modeling. Simulating market crashes or sudden volatility requires immense computational power. Researchers say quantum algorithms could enhance the accuracy of these simulations, helping institutions prepare for worst-case scenarios with greater precision. While these applications remain largely experimental, pioneers like JPMorgan Chase and HSBC have already begun testing quantum models in controlled environments. The challenge, of course, lies in scaling these breakthroughs to real-world conditions. As the technology matures, financial institutions may find themselves at the forefront of the quantum revolution. But for now, the promise remains just that, until the hardware catches up. In 2022, JPMorgan explored quantum computing to refine portfolio optimization strategies, testing algorithms designed to balance risk and return more efficiently than classical models. While the results were promising, the firm noted that quantum computing had not yet reached a stage where it could replace existing financial tools. A recent report from the U.S. National Science Foundation highlights how quantum systems excel in solving complex optimization problems, such as those found in logistics and supply chains, by processing vast combinations simultaneously. Take, for instance, the challenge of simulating molecular interactions in drug discovery, where quantum computing's parallelism offers a clear edge. JPMorgan's trial underscores a broader trend. Quantum computing is not just about speed, but about solving problems that classical systems struggle to manage. As researchers continue refining quantum hardware, the financial sector remains a key testing ground. The next scene will explore how startups are pushing the boundaries of quantum machine learning. Quantum computing is reshaping the boundaries of what's possible. Unlike classical computers, which process data in binary, quantum systems leverage qubits to handle vast, complex calculations. Researchers at the U.S. National Science Foundation highlight how this shift could revolutionize fields like drug discovery. Simulating molecular behavior, a task that can take classical systems years, might be achieved in days with quantum machines. Picture this: a pharmaceutical company modeling protein interactions to design a new cancer treatment. The complexity is staggering, but quantum computing could cut through it. Another area is logistics. A recent report found that quantum algorithms could optimize global supply chains, reducing delays and costs by analyzing millions of variables in real time. This isn't just faster computing, it's solving the unsolvable. As we approach the final frontier of this quiet revolution, the next scene reveals how quantum science is changing the way we think about innovation itself. The future of quantum computing hinges on solving persistent technical hurdles and proving its value in tangible ways. Researchers at the U.S. National Science Foundation highlight how quantum systems could revolutionize drug discovery by simulating molecular behavior far beyond the reach of classical computers. Take, for example, the challenge of modeling complex proteins, something that could unlock new treatments for diseases like Alzheimer's. Another frontier lies in logistics, where quantum algorithms may optimize global supply chains, saving industries millions. But these promises remain theoretical without scalable, error-free quantum hardware. Startups and tech giants alike are racing to build fault-tolerant systems, with some predicting breakthroughs within the next decade. If quantum computing can deliver on these real-world problems, it may well redefine entire industries. Until then, the revolution stays silent. If this glimpse into quantum's potential intrigued you, hit that subscribe button and check the description for sources. Let's keep the conversation going in the comments.